Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at section 3.3. This is on triangles, regular hexagons, and irregular polygons. So the first thing we're going to take a look at here is the Pythagorean theorem. We've probably, at least hopefully, heard of this before. Maybe seen it in some of our either junior high or high school classes that we've taken. But if not, we're going to go through it. So the idea here is that if we have a right triangle, and that is a triangle that has a right angle in it, which is usually denoted by making a little square in the corner. So that's the right angle. Then we have an equation that works with this triangle. And that is c squared is equal to a squared plus b squared. Now, c is the hypotenuse. That's always the side that is not touching your right angle here. And then A and B are the legs, and those are the sides that are touching your right angle here. So that's how we distinguish between the legs of a right triangle and the hypotenuse of a right triangle. So let's go ahead and take a look at an example here. All right, suppose we have a triangle, looks like this. It has a side length of 6, and it also has a side length of 10. How do we find this last measurement here? Well, we're going to use the Pythagorean theorem. So we have the formula, and if you want to go ahead and try this first, you can. Just unpause the video when you're ready to go through the solution. All right, so we have the formula c squared is equal to a squared plus b squared. All right, now what do we have? It looks like here's the right angle. So we have one side that's touching the right angle. That would be considered a leg. So we can either put that in for A or B. And then we have one side that's not touching the right angle. So that is going to be our hypotenuse. So that is definitely going to be C here. So I need to replace the C with the 10. And then I can either replace the A or the B with the 6. It doesn't matter. So I'll go ahead and do the A plus b squared. All right, so once I do that, next thing I'm going to do is square those out. So I have 100 is equal to 36 plus b squared. Now I'm going to subtract 36 from both sides, so I get the variable b squared by itself. So that's going to give me 64 is equal to b squared. Next thing I'm going to do is I'm going to go ahead and take the square root of both sides. So take the square root of 64 and also take the square root of b squared. The reason I'm doing that is because the square root of b squared is just going to give me b back. And then the square root of 64, normally it would give me plus or positive or a negative 8. But since we're looking at lengths here, we're only interested in the positive length. So that is going to be 8. So this length side over here is equal to 8. And that's pretty much how we solve them. Now, if we were solving for the hypotenuse, then we would leave the c squared here, and we would take the other two sides and put them in for A and B, square those out, add them together, and then take the square root of both sides. All right, let's go ahead and take a look at the next topic here. All right, so let's kind of take a look at finding the areas of triangles here. Now, here's the most common formula that we've seen, and that is the area is equal to 1/2 the base times the height. So if we know two dimensions that are both perpendicular to each other, that means that they meet at a right angle, then we can use this formula here. So for example, if we were to know this side length here and then the distance to the top of the triangle that is perpendicular to the base here, we could use the area of the triangle 1/2 base times height. So let's go ahead and take a look at that here. So let's say I had a triangle and I knew that, let's say I knew that this side over here was 13, and then I knew the length that was perpendicular to that side. So it's the distance that meets that side at a right angle here, and I knew this length here was 11. Then I could use this formula here, and that would be area is equal to 1/2 times my base. My base would be that side here, 13, times the height. The height would be the distance that was perpendicular to our base, so that would be times 11. So this would be, now let's go ahead and use the calculator. So for this one, I could write 1/2 is 0.5 if I want. 0.5 times 13 times 11. And I'm going to get 71.5. So that would be 71.5. And remember, if we were talking about, let's say this was in meters here, and this was in meters, then this would be meters squared. Now I have a couple more formulas that work in other kind of specific situations where we don't have those two distances that are perpendicular to each other. The first one works for an isosceles triangle. An isosceles triangle is a triangle where two of the sides are the same. And let me get rid of that. Okay, so the area of the isosceles triangle where we have two sides that are the same is 1/2 times the base times the square root of the side that's duplicated, so the side that appears twice, squared, minus the base over 2 quantity squared. So kind of a tricky formula, but let's go through. So try this one here using this formula, and then we'll go through the solution. So when you're ready, go ahead, pause the video, and then unpause it. All right, so first things I want to do is I want to identify B and A. Remember, B is the distance that only comes up once, so that's going to be 6 in this case. So B is equal to 6. And then my A is the distance that appears twice in this, so that would be 12. So I'm going to go into this formula here. I'm going to replace my A's with 12 and my B's with 6. So I'm going to have the area is equal to 1/2 times B, 6, times the square root of 12 squared minus B, that would be 6 over 2 quantity squared. So I could really just put all of this into my calculator, just making sure that I put parentheses around everything here, just to make sure that it uses the correct order of operations. But I can also kind of figure this out by hand, at least most of it. So 1/2 times 6 is just 3, because that's just half of 6. And then we're going to have times the square root of 12 squared, which is 144, minus, remember we do in parentheses before we do exponents, using the please excuse my dear Aunt Sally, or PEMDAS. So that would be 3 squared, which is 9. And then this is going to be 3 times the square root of 144 minus 9, which is 135. Square root of 135. And I don't know if we can simplify that square root of 1. Hold on. Calculator there. So you can also make sure that there's no perfect square factors here that we can pull out. But I don't think that there is, but I'm going to double check real quick. It actually appears that there is. So 135 is divisible by 9, and 9 is a perfect square. A perfect square is a number that when you take the square root of it, you get a whole number back. So when you take the square root of 9, you get 3 back. So we can rewrite this as 3, and then we can break up the 135 into the square root of 9 times the square root of 15. And then we're going to end up getting 3 times the square root of 9 is 3. So 3 times 3 is 9 times the square root of 15. And that would be our final answer there. Heron's formula, the equilateral triangle formula just means if all the sides are the same, you can use this formula here. This is an approximation. That means it'll give you a pretty close, usually out to the third decimal place, approximate area. And then Heron's formula. That's the one that I think most students have trouble with. So let's go ahead and take a look at that one. All right, so Heron's formula says that if we have any triangle at all, it doesn't have to be a right triangle, it doesn't have to be isosceles, it doesn't have to be equilateral, but for any triangle, if we know all three sides of it, we can use this crazy formula. So this says the area is equal to the square root of s times s minus a times s minus b times s minus c, where s is equal to the sum of all of the sides divided by 2. So let's at least take a look at an example of that one. So if we have a triangle, here, let's just say it looks like this, and let's say that this side is 13, this side is 14, and this side is 15. And we want to find the area of that. I can use this formula. So, so if you want to go ahead and try it, go ahead, pause the video now, give it a try, and then we'll walk through the solution. All right, so the first thing I want to do is figure out what this s is. So I'm going to do s. So that's all the sides added together. So 13 plus 14 is 27, plus 15 is 42. So that's going to be 42. Because I just added up all the sides, a plus b plus c, and divided by 2. So that's going to give me a 21. So now that I know my s, I can put it all in this big formula here. And so a is equal to the square root of s, 21, times s minus a, so times 21 minus, doesn't matter, I'll do it in chronological order. So this is A, this is B, and this is C. So 21 minus A, which is 13, times S minus B, so that would be 14, and then times S minus C, which is 21 minus 15. All right, so pretty crazy. We can simplify this a little bit before I put it into my calculator here. But this is going to be 21 times 21 minus 13 is 8, times 21 minus 14, which is 7, times 21 minus 15, which is 6. So this is going to be equal to the square root of 21. So I'm going to put this in my TI-30XS calculator. So I'm going to do the second square root of 21 times 8 times 7 times 6. So if you look at that here, I don't know if you can see that, but this is how I put it into my calculator right there. And hit enter. And I get, wow, I got a whole number there. I got an 84. 84. So that would be the area of this triangle here. All right, let's move on to the, I believe it's the regular hexagons. All right, so a regular hexagon is a 6-sided polygon where all the sides are the same length and all of the interior angles here are also the same measure there. So if we know the length of one of the sides, remember all the sides are the same, but we can put it into this formula here, which is 3a squared times the square root of 3 over 2. And if we know the dimensions of possibly a side or a flat goes from the middle of one side to the middle of the other side, or the diagonal goes from one of the corners to the opposite corner. We have these formulas here to help us find the other distances. So let's go ahead and take a look at an example. All right, so let's say we are given a regular hexagon with a side length of 6.2, and we wanted to find the area, the distance of the flat, and the distance of the diagonal. And how would we do that? So if you want to go ahead and give this a try to find all three of those measures, go ahead and pause the video now, and then when you're ready, go ahead and unpause it. All right, so to find the area, I'm just going to plug in that 6.2 there. So this is going to be 3 times 6.2 squared times the square root of 3 all over 2. Or if I just needed an approximate value, I could plug that side length into this formula here. But either way, this one is going to give me an exact formula, an exact measure here. So 6.2 squared, let's use a calculator for that. So 6.2 squared, that's 38.44, and then we're going to multiply that by 3. So times 3 is 115.32, and then we're actually going to divide that by 2. So we're going to divide that by 2. I'm going to get 57.66, and then times the square root of 3. So 57.66 times the square root of 3. So now this is actually the exact value here. If we wanted to approximate that value, that's where those little squiggly equal sign is. I can just multiply that 57.66 times the square root of 3. So times second square root of 3. And if I went to 3 decimal places, that would be 99.870. So 99.870. That would be my area. Let's say this was in inches here. So my final answer would be in inches squared. And then let's say I want to use this formula here just to get that approximation, make sure that comes out to the same thing. So I could also just do the 2.598 times the 6.2 squared, 6.2 squared, just like that. And you'll see I get a value that's very close to this one here. It's an approximation, so it's normally not going to be the exact value, but it'll give me one that's close. All right. But now that we need to find the flat and the diagonal. So the diagonal is just twice the side length there. So D is equal to 2 times A, which is 6.2. So that's just going to be equal to 12.4. And the flat, we have an approximation formula for that. So that's approximately equal to 1.732 times our side length here. So I'll need the calculator for that one. And that is going to be equal to 1.732 times our side length, which is 6.2. I get 10.738 if we round to 3 decimal places. 10.738. 10.738. And remember, these squiggly equal signs over here mean that this is just an approximate value for that flat. All right, guys. The rest of the problems are going to be a lot of word problems and kind of breaking down other shapes into triangles and other types of polygons, like the ones that we looked at last section, for example, parallelograms and rectangles and trapezoids. So see how far you can get, and please let me know if you have any questions. Thank you.